Imagine a pendulum swinging back and forth. We want to find out how long it takes to complete one full swing, called the time period. The forces acting on the pendulum's bob are: at the pendulum's highest point, two forces act on the bob, the weight at the end, mg, tension, T, pulled up by the string. We can break down the weight into two parts. One part mg cosine theta balances the tension, so the bob doesn't fall. The other part mg sine theta creates a restoring force that pulls the bob back to its starting position. Pendulum's swing is small. We can simplify the math. Sin theta is equal to theta. Restoring force equals mg times theta. Using Newton's laws, we get restoring force equals m times a. Therefore, equating the right-hand side, m times a equals mg times theta. Theta is related to the length of the pendulum, L. So, m times a equals mg times x/L. Acceleration a equals g times x/L. Connecting to simple harmonic motion, acceleration also equals omega square times x, from simple harmonic motion. Equating the two, we get omega square x equals g times x/L. Therefore omega is equal to root of g by L. Time period formula. Finally, we connect omega to the time period. 2 pi by t is equal to root of g by L. Therefore time period is equal to t equals 2 pi times square root L/g. This formula shows that the time period depends on the length of the pendulum and gravity. In simple words, the longer the pendulum, the longer it takes to complete one swing. Gravity affects the pendulum's swing speed. That's it.